Eric Burgess here. We've been told to determine the convergence or divergence of this thing, and then it says find the sum if it is convergent. So we say, okay, we're looking at this, and we've got an oscillation here, a plus minus, so that's going to be a fun bit. But just looking at this, we've got a 4, a 16, and a 64, which are all powers of 4. And on the bottom, we've got a 3 and a 9. And so this is powers of 3. So just first look, we just say, okay, well, this is kind of strange. So what I like to do is I like to start rewriting it until I begin to see it. So if I write this as 4 to the first, right, and then underneath, if this is really powers of 3 down here, then wouldn't it make sense that this is 3 to the 0? So this would be 3 to the 0, 4 to the first, 16 is 4 squared, and 64 is 4 cubed. And then we've got 3 to the first, and 9 is 3 squared. So the only sort of oddball thing we've still got left is this 3. And just looking at this, I say, well, it would make sense that this would be 3 because 4 would become 4 to the 0 here, and 3 would become 3 to the negative 1, which would become 3. So we could even rewrite that. We could say this is the same thing as 4 to the 0 over 3 to the negative 1 plus all the stuff above. So our pattern fits. And so we say, okay, well, can we turn this into a series now? This is a lot easier to see what's happening. So we say, okay, well, this is the same thing as the sum. And on the bottom, we've got 3. And we're going to start off n at 1 and go to infinity. So this is n minus 1, right? Because we want to start off at 3 to the negative 1. And then on the top, we've got a 4. And in this case, we want 4 to start off at 0. Oh, you know what? This is 3 to the minus 2. Right? And the reason for 2 is because if we put a 1 here, it's going to be 1 minus 1, which would be 0. But our first term is 3 to the negative first. So this to be n minus 2. That way, 1 minus 2 is negative 1. That'll give us that initial 3. And we want 4 to start off at 0. So if n starts off at 1, we want to subtract 1. So, and we know that this is an oscillating sequence, so we can take care of that by just putting in negative 1. And we want it to start off, what do we want to start off as? We want it to start off as positive. So we'll just do n minus 1. This will make it 0, which will give us a positive at the beginning. So we say, you could also write plus 1. It'll give you squared, which will also give you positive at the beginning. So we look at this and we say, okay, this is kind of mean looking. Like, how do we deal with this? And the answer is we're going to break up this through algebraic manipulation. So this is the same thing. I'm just going to write sigma from here on. Just know that n is 1 and we're going to infinity. This is the same thing as 3 to the negative 2 times 3 to the n. And this is the same thing as 4 to the negative 1 times 4 to the n. And then, of course, we have the minus 1 times n to the minus 1. The minus 1 times n to the minus 1 isn't going to matter as much. We're going to take this, and this is the same thing as. And so this is going to be 3 squared divided by 4. That's just some constant. That's our a. And then we've got our 4 over 3 to the n times negative 1 n minus 1. And this one is our r. Now looking at this, we say, oh, well, this is pretty interesting because we say that, okay, r, the absolute value of r, is greater than 1. Therefore, it's divergent. Now, if this bit here bothers you, there's a way to actually push it into the r, right? Because we could write this bit as negative 1 times n times negative 1 to the negative first. And then negative 1 times n can be pushed into the 4/3 n. I think this way is a little clumsy to look at it, though. And so we could actually come over here and just say, well, we want this negative 1 here to be n minus 1. But we've already got an n minus 1 term. It's right here. So we could have written this step, if you so chose, as n equal 1 to infinity of -4 to the n minus 1 over 3 to the n minus 2. And then this would have fit into the r, and it would have made that thing there a -4. But we only care about the absolute value of r. And so if you're a little concerned about why I don't care about this, that's the reason why I don't care. And we only really care about what's going on with r, and there's a way to push the negative into r. And so it's not going to impact anything. So this is going to be our answer. If you have any questions, free to drop them down in the comments, subscribe and hit that bell icon for future videos, and we'll catch you in the next problem.